Lesson 8.1, what we're going to do is we're going to totally change gears from what we've been doing in Chapter 7. Chapter 7, we dealt with equations of lines. We dealt how to graph those lines, solutions to systems of equations. And now we're going to change gears to Chapter 8, which is exponents. The reason why we're doing this is Chapter 7 was all about lines and graphing. Chapter 8 is all about exponents. Chapter 9 combines the two. So we're going to do graphing and exponents and equations. So we need to get this so that we can get Chapter 9. Now, one thing I do want to tell you about Chapter 8. A lot of the answers that you will get can be found by using your calculator, which is fine. I do not mind if you use your calculator, but you must show all work because I need to know, especially on lesson 8.1, there are rules that you have to follow and simplification processes. And you have to show me that work because I need to know that you know how to do that, okay? So, what we're going to talk about is we're going to talk about the 3 rules first for simplification. 3 rules. Now, these are more of a formality, the name of each of these things, the properties, the product of powers property, the power of a power property, the power of a product property. Okay, sounds pretty confusing, right? Well, what we're going to do is I'm basically going to show you how to do this, all right, with using your, basically you just need to know how to do it. So we're going to talk about this, talk about the rules, and then we're going to apply it. First of all, adding the exponent, product of a power property. What we're going to do is we have 2 bases that are being multiplied. So let's say I had something like x squared times x to the 3rd power. What we have in here is we have the same base. Everybody see the base? Everybody understand what a base and an exponent is. If you don't, if I had a problem like this, 5 squared, 5 would be considered my base, and 2 is considered your exponent. For all you cheerleaders out there, where's the base? The person at the bottom of the pyramid, okay? That's what you have here, your base. Your exponent is your smaller number up top, okay? So here's our base, x and x. Since they're the same, I can go, I can simplify this and make it look a lot easier. Since they're both x, I just write it one time, and all you need to do is add your exponents together. What's 2 plus 3? 5. X to the 5th power would be my final answer. Okay? So anytime I have the same base and they're being multiplied, I just add the exponents together. Now, if you had a problem that looked like this, let's say you had 3 squared times 3 to the 4th power. Do I have the same base? Yes. So I'm just going to write it one time. And what do I do with the exponents? Add them. 2 plus 4 is 6. Now, when you have a number like this, this is not your final answer. Now is when you plug it into your calculator and you would simplify. So I have 3 to the 6th power is 729. This step right here is absolutely necessary because that shows me you know the rules. You know that I add the exponents. Because technically, in your calculator, you can plug in 3 squared times 3 to the 4th power, and your calculator will tell you your answer is 729. That's fine. If you want to do that to check your answer, that's great. But this step right here has to be shown. If you don't show it, you don't get any credit. Now, there's one other type of problem that you're going to run into on these, and that's something that may look like this. Oops, hold on. Let me rewrite that. Do I have the same bases here? Yes. But what about this first 2? What is the exponent? 1. Anytime you do not see the exponent, it is 1. So I have the same bases. They're being multiplied. So I can rewrite it as 2 to the 4th power. Simplify that, and I get what? Get out your calculators. 16 is my final answer. Again, you always want to simplify it as far down as you possibly can. Okay? But this step you do have to show. All right, so let's put that into practice. Before we talk about the other two rules, let's go ahead and do some problems that look like that I would use this property. In this first problem, Abby, do I have the same bases? Yes. So how am I going to rewrite this? 5 to the 9th power. Perfect, because all I did was add the exponents. Now, one thing that I do want to make sure you understand, you never, ever, ever multiply your bases. You keep it the exact same. Okay, so it's 5, and then you just add the exponents to the 9th power. Can I simplify this even farther? Yep. What's 5 to the 9th power? Who's got that? Plug it in your calculator. 1,953,125. Yes, you have to simplify this all the way down. Every time you're doing these problems, when you finish one step, say, can I simplify farther? If your answer is yes, keep going. If it's no, then you stop right there. Okay? Look at this next problem. Do I have the same bases? Yep. Are they being multiplied? Yep. So I just add my exponents. But what do you see that you need to write? Does -2, the first one, it needs an exponent of 1. So it's going to be -2 to the what power? 5th. Because you add them. What's -2 to the 5th power? -32. Perfect. And last one. Are all of these the same base? Yep. So I can rewrite this x to the what power, Cameron? 9th power. Can I simplify x to the 9th power? No. So this is my final answer. Now you could write out x times x times x 9 different times, but you do not have to do that, okay? That doesn't change, that doesn't solve anything. All it does is make you do more work. All right? So that's how we do product of powers. If we have the same bases and they're being multiplied, we add the exponents. All right? Let's go back now to that first slide, and we have a power of a power. Basically, what you have on these problems is you will have one base. So I'll have something like 5 squared. And that 5 squared is also going to be raised to the 3rd power. So when you have a problem that looks like this, all you got to do, multiply your exponents. I keep my base, which is 5, and my new exponent is going to be 6. Plug that in my calculator and simplify. 5 to the 6th power is 15,625. Also, if you had something that looked like this, how would you rewrite that, Kiera? What am I going to do with these exponents? Multiply them. So 4 times 8 is 32. X to the 32nd power, okay? Don't get that mixed up with the first one, which we added, okay? Here's a good way for you to remember. If you've got more than one base, we had 2 or 3, you always add the exponents. If you only have one base, you're going to want to multiply them, okay? So let's put that one into practice. These problems right here. Victoria, what am I going to do with this first problem? Do I want to add them or do I want to multiply? Multiply, because 3 times 2 is 6. 3 to the 6th power is Who's got it? 729. All right, Rashid, what am I going to do with my next problem?
Multiply 4 times 4.
Which is?
16.
So p to the 16th. Can I simplify that any farther?
No.
Nope. That is my final answer. Okay, the last rule. Oops. Is power of a power. Okay? You say, all right, what does that mean? This is exactly what it means. If you have something, oops. If I had something like this, what would you do first? What would you think you would do first?
Multiply inside.
Multiply inside. It makes it so much easier. What's 6 times 7? 42. And I have 42 squared. I cannot forget about that. 42 squared is 1,764. But what if I had one like this?
It would be 2x and you'll multiply the third.
With this 3 on the outside, that means this 3 has to be distributed to everything inside the parentheses. So I'm now going to have 2 to the third power times x to the third power. And I simplify what I can. Can I simplify 2 to the third power? Yes, which is going to give me 8. Can I simplify x to the third power? Nope, so I just write 8x to the third. Does everybody see what we did there? You just distribute that exponent to everything in parentheses. Okay, let's put that one into practice. All right, Trent, what would I do first on this first problem?
Multiply -6 times 5.
Which is?
-30.
Perfect. -30 squared. Now stop right here and pay attention. Listen to this. If you plug this in your calculator, -30 squared, your calculator is going to tell you your answer is -900. That is wrong. That is wrong. Anytime your exponent is an even number, your answer should be positive. Because -30 times -30 is what? Positive 900. Okay? Now, if you want to use your calculator, obviously you're going to want to use your calculator. If you ever have a negative base, what you want to do is put that base in parentheses. So I could do the parentheses, -30 parentheses, then do my squared. And it tells me my answer is positive 900. Okay? Or you can just plug it in. And remember, okay, if I have an even exponent, my answer is going to have to be a positive answer. Okay? Next one. What would I do here, Marcus?
This one you would, I think you put them in the exponent.
Okay. What am I going to do with this exponent right here? Distribute it to everything inside of parentheses. That means the 4 has to be to the third power. The y has to be to the third power. And the z has to be to the third power. What is the only thing left to simplify? 4 to the third power, which is 64. Y to the third power, z to the third power. Could I add these exponents right here? No, because they don't have the same base. Y and z are different. So this would be my final answer. Okay? The last type of example that we are going to do is we are going to use all 3 properties. So we're going to have to just combine them all. And remember, the question you want to keep asking yourself is, can I simplify it farther? Can I simplify it farther? If the answer is yes, keep going. So look at this first problem right here. What should I do first, Brittany? Okay, I can multiply the 2 and the 3, but what else is in parentheses that also needs this exponent of 3? The 4. So I need to write 4 to the third power, x to the what power? 6. Okay, the reason why you multiply is basically you are distributing that exponent. What do you do when you distribute? Multiply, always. So I have 4 to the 3rd power, x to the 6th power, times x to the 5th power. Can I simplify this farther?
Yes.
Yep. 4 to the 3rd power is 64. Are these the same bases and are they being multiplied?
Yes.
Yep. So I can change it to an x, and what is my new exponent going to be? 11. All you got to do is add the exponents. Okay. Let's do this last one. Same exact thing. Abby, what am I going to do first?
Multiply 4.
Okay. First of all, how many terms or how many things do I have inside parentheses? 2. I've got a 3 and an x to the 4th. So what you cannot forget to do is distribute it to everything. Okay? If I gave you a problem like this, you would have to distribute that 5 to everything. Same exact thing. This is on the outside of the parentheses. It has to be distributed to everything. So now I have 3 squared x to the 8th power, don't forget, and you need to multiply there, not add, times x to the 3rd. What would I do now, Brianna?
Do 3 to the 2nd power.
3 to the 2nd power, which is 9. Then what am I going to do, Lizzie?
Put the x and then add 8.
Very good. X, and then you add the 8 and the 3, which is 11. And that is my final answer there. Okay? That is how we simplify using exponents.